Hello and welcome to this GCSE Science revision video for additional physics on energy from the nucleus. In this video we will look at fission and fusion, the early universe, the life cycle of a star and how new elements are formed. Nuclear fission is a process of splitting a nucleus into smaller parts. Fission is another word for splitting. Uranium or plutonium isotopes are normally used as fuel in nuclear reactors. Their atoms have a relatively large nuclei that can be split easily, especially when hit by neutrons. When a uranium-235 or a plutonium-239 nucleus is hit by a neutron, the following happens. The nucleus splits into two smaller nuclei known as daughter nuclei, which are radioactive. 2 or 3 more neutrons are released. Some energy is released in the form of kinetic energy of the particles produced. This then produces heat. The additional neutrons released may also hit uranium or plutonium nuclei and cause them to split. Even more neutrons are released, which in turn can split more nuclei. This is called a chain reaction. The chain reaction in nuclear reactors is controlled to stop it moving too quickly. Nuclear fusion involves two atomic nuclei joining together to make larger nuclei. Energy is released when this happens. The Sun and other stars use nuclear fusion to release energy. The sequence of nuclear fusion reactions in a star is complex, but overall hydrogen nuclei join together to form helium. The universe developed about 13.5 billion years ago. It is only a theory of how we think it evolved, so there is no particular hard scientific evidence as conclusive proof. The theory begins with the Big Bang, which is auto theory. It says that the entire universe and everything in it was at one compressed point that was very, very hot at the start of the universe. Scientists have calculated that the universe is approximately 15 billion years old. Well, between 13.5 billion years and 15 billion years old. Before the Big Bang, there is no concept of time. The universe is infinitely small and infinitely hot. The forces that we know, such as gravity or electromagnetism, did not exist. 1 second after the Big Bang, the first particles started to form. It was still incredibly hot, so only particles can exist. The only particles that existed were protons and neutrons. Many thousands of years later, protons and neutrons came together to form the nuclei of simple elements such as hydrogen, lithium and helium. This is known as the radiation era of the universe. There is still little matter, which is stuff, and the universe is mostly full of high-frequency electromagnetic radiation. Next, we begin the era of matter. The temperature now dropped low enough for electrons to bind to the nuclei of the atoms to form the atoms that we now know and that are electrically neutral. The gas eventually started to come together under gravity and the earliest stars were formed. Stars have a long lifetime dependent on how big they are. They all begin with the nebula. The space between the stars is not empty. It is filled with gas and dust particles referred to as interstellar medium or interstellar matter. Gases make up most of the interstellar medium, with the dust accounting for only a very small amount of the total mass. The gas is mostly hydrogen and the dust contains tiny grains of silicates, graphite and iron. Interstellar matter clump together to form large clouds called nebulae. As the dust and clouds become denser, they acquire more mass. The gravitational interactions between the particles can overcome the outward pressure of kinetic energy. This creates a gravitational instability and causes a gravitational collapse of the cloud. This is when the clouds collapse into small bodies under the action of their own gravity. During the collapsing or concentration of the cloud, the material in the center of the cloud heats up due to the transfer of gravitational potential energy into thermal energy. This hot core at the center is called a protostar. After this point, the star goes into its main sequence where fusion is taking place. Towards the end of the main sequence star stage, all of the hydrogen in the core of the star is exhausted and transformed to inert helium. Without the hydrogen, the thermonuclear reactions at the core stop and gravity compresses the core into a smaller size. Surrounding the core is a layer of hydrogen. Gravitational contraction provides enough energy for the nuclear fusion of the hydrogen in this layer. The outward pressure from the nuclear reaction prevents the star from collapsing and makes it expand to several hundred times its former size. Due to the expansion of the outer layers, the energy from the hydrogen layer is spread over a larger surface area, resulting in lower surface temperature and shift in the star's outward output to the red wavelength of light. The star has now become a red giant. The end of the star is dependent on its size. Small stars end up as white dwarfs. Massive stars go supernova, then turn into a neutron star. And supermassive stars go supernova, then turn into black holes. New elements form as a result of nuclear fusion within stars. To start this, we start off with nebulae. So something causes the nebulae to be squeezed together at the start. The squeezing made the cloud start to collapse. As gravity pulled the gas and dust together, it formed a solar nebulae. It spins faster and faster, which means that the gases in the middle of it got denser and gained more energy until nuclear fusion could take place. Once the cloud of gas becomes suitably hot, then fusion takes place and a star is born. As we go through, please pause the video to have a go and think about the questions in the yellow boxes. Nuclear fusion in the center of the star caused two forms of hydrogen to fuse together to form helium. At this stage, the outward force caused by nuclear fusion was equal to the inward force caused by gravity. This caused the star to be stable. Once the hydrogen runs out, the fusion stops and gravity takes the lead and compresses the star into a smaller and tighter ball. The temperatures increase with the concentration, eventually reaching levels where helium is able to fuse into carbon. The energy produced when helium fuses into carbon causes the star to expand outwards. So, helium fuses together to form larger elements, not just carbon. It can also form things like beryllium and anything anywhere between helium and carbon in the periodic table. As carbon's made, the star expands as this releases more energy. After the carbon has been, all the helium and hydrogen has been used up to form carbon, the star begins its first declines to go in supernova. So once all the helium has been used up, fusion stops again, so the force pushing in is greater than the force pushing out. This causes newly formed elements to fuse into heavier elements such as neon and magnesium. As the core becomes denser, the magnesium and oxygen atoms start to fuse together to form silicon and sulfur. The silicon and sulfur fuse together in a tightly compact iron core. When the core reaches its maximum scrunch, it collapses at speeds of up to 45,000 miles per second, and the star goes supernova and explodes. So remember, when revising, turn off distractions, keep asking yourself questions, quality of revision is better than quantity of revision, and use things like flashcards to help you revise. Good luck with your physics exams.